In this question, we can use some of the circle theorems, and one circle theorem says that this angle here is the same as this angle here. Now, I don't know what they are, but I'm just going to call them both x. So that if that is x, then that is x. I'm just actually going to do a quick proof of it. Circle theorem is one of the best topics, I think, on GCSE maths, just because it introduces, yeah, well, there's so many proof ideas you can bring in, and just lots of areas like linking together. Okay, so I'm going to say again, this is x, and then I can draw a line coming down to where the tangent meets. Now I need to use another circle theorem to help me with this proof, and that is that the radius meets the tangent at 90 degrees. So this angle is going to be 90 minus x. And now if I also draw the radius to that point, then I've created an isosceles triangle, and that is also therefore 90 minus x, which means the middle angle is going to need to be 2x because the three of them have to add to 180. This brings in one of the circle theorem that the angle at the center is twice that of the circumference, which means this also has to be x. There's other ways you can prove this without requiring the two circle theorems that I've used. I don't think you could get away with not using the right angle one, but anyway, that we can build maths on top of each other and hence prove what we call the alternate segment theorem. So that's where I've got x from and x from here. I'm then going to be able to say, okay, right, one of the circle theorem is that tangents meeting at a circle like this, they are the same length. So that red length there is the same as that red length there. So this is also x. Okay, so actually 3x is on there. Now I'm going to do similar for y. This is y, which means that this is y by the alternate segment theorem, and that is also y because of this isosceles triangle. Again, that circle theorem says these two are equal. Now I can see down here that x plus y plus 55 is 180. So it must be that this missing angle here is 55. And it might have seemed surprising that we can get that angle at the top, since we just had the 55 at the start, but it's all coming together now. This is also 55. So finally, I mean, I didn't even need to work down the right-hand side. Like you could use the fact that it is isosceles, but I've justified it. So now I'm just left with this purple triangle. The two angles add up to 110, meaning that this one must be 180 minus 110, and the answer is going to be 70. Great question.